with the next one. This is why the so-called simplest of cells is called the paramecium. When they examine it, it's actually more complex than the space shuttle, which, by the way, was made by a team of engineers and designed last time I checked. And that's the so-called simplest one. There's no such thing. Let me finish on this. It's called the bacterial flagellum, right? This is not the E. coli bacteria. This is just the tail. You'll see a video in a second that propels the E. coli bacteria around. Watch how intricate this thing is. This thing consists of 40 individual protein parts. It's got a stator, a rotor, a drive shaft, a U-joint. It makes it a propeller in the microscopic world. And you go, well, how does that thing run if it's a motor? Well, it creates its own electrical power to run by developing a voltage difference across the cell membrane. So it creates its own charge. Well, is it a good motor? Yeah, watch this. This thing runs at an incredible 100,000 RPM. It could stop on a microscopic dime, make a quarter turn, shift direction, start spinning immediately 100,000 RPMs in the opposite direction. We can't design a transmission to do that. It'd fry every time. This is just the tail on a bacteria that God made. It's crazy. In fact, it's water cooled, it's got 2 gears, forward and reverse, and it travels about 1 micron per second. And you go, that's amazing, I have no idea what that means. Well, let me describe it for you. Watch this. That's equivalent to you and I swimming 60 miles an hour through peanut butter. That's a lot of torque. That's a pretty good motor. Now, here's what's wild. When this first came out in the scientific community, they were excited about it, right? And it was actually featured on a PBS show called Unlocking the Mystery of Life. And then they started getting people going like, there has to be a God. They pulled it. You liar. Okay? In fact, here's a little portion of what they didn't want you to see on that special. Watch this.
There are as many molecular machines in the human body as there are functions that the body has to do. So if you think about hearing, seeing, smelling, tasting, feeling, blood clotting, respiratory action, the immune response, all of those require a host of machines.
When we look at these machines, we ask ourselves, where do they come from? And the standard answer, Darwinian evolution, is very inadequate in my view.
In speaking on the topic of scientific naturalism and evolution...
During the early 1990s, at a series of academic conferences, Behe first shared his doubts about the ability of natural selection to construct complex molecular machines. One machine particularly attracted his attention.
I remember the first time I looked in a biochemistry textbook and I saw a drawing of something called the bacterial flagellum with all of its parts in all of its glory. It had a propeller and the hook region and the drive shaft and the motor and so on. I looked at that and I said, that's an outboard motor. That's designed, that's no chance assemblage of parts.
Behe's reaction was not surprising, for the molecular motors that drive bacteria through liquid each depend upon a system of intricately arranged mechanical parts. These parts come into focus when portions of a cell are magnified 50,000 times. Biochemists have used electron micrographs like this one to identify the parts and three-dimensional structure of the flagellar motor. In the process, they have revealed a marvel of engineering on a miniaturized scale.
Howard Berg at Harvard has labeled it the most efficient machine in the universe. These machines, some of them are running at 100,000 RPMs and are hardwired into a signal transduction or sensory mechanism so that it's getting feedback from the environment.
And even though they're spinning that fast, they can stop on a dime. It only takes a quarter turn for them to stop and shift directions and start spinning 100,000 RPM in the other direction.
And just like outboard motors on motorboats, it has a large number of parts which are necessary for the motor to work.
The bacterial flagellum, 2 gears, forward and reverse, water cooled, proton motive force, it has a stator, it has a rotor, it has a U-joint, it has a drive shaft, it has a propeller, and they function as these parts of machines. It's not convenient that we give them these names. That's truly their function.
Since its discovery, scientists have tried to understand how a rotary motor could have arisen through natural selection. As yet, they have failed to offer any detailed Darwinian explanation.
But don't worry, we call that the X factor. And